So today we're working with a Tormach 8L lathe, and I'm going to go over a quick overview of the machine and show you some of the features, functions, work holding tools, how to load up material and load up your tools in order to cut that material. First thing that we need to do is turn on the machine. If you want to move the camera, the button or switch to turn on the machine is going to be on the right side of the machine. It's a red switch. We just want to turn on to the on position. Once we have it on, the machine's going to light up. The controller will turn on as well, so we have to give it a minute to boot up here. Now while that's booting up, you can check to make sure your e-stop is off. And we can also click on the reset button here. When we click on the reset button, it should glow blue, taking the machine out of e-stop mode. I'm waiting for it to turn on. There we go. The first thing we want to do when we turn on the machine is we have a blinking reset button that we want to make sure we click. And that will also tell the controller here we've taken the machine out of e-stop. Now we have to reference our axis, which our two axes are X and Z. Our reference buttons are going to be the reference X and reference Z located at the bottom right near exit. I'm going to go ahead and click on reference X, and the machine is going to move on the X axis to touch off on the limit switch to know where its 0 is, and we're going to do the same thing with the Z. Sweet. Now our machine is ready to run. It's all booted up, all started. All we need to do is load material, load our tools, and give it a program to run. I'm going to go quickly over the software here for those who aren't familiar with it. Right now, our first tab that we're in our main tab where we get to see G code. Right now we don't have any G code because we don't have a program loaded onto here. And we can always edit that G code or insert our own set of G code into our box that we can type into. Now down here, this is all the controls for the machine. We have our cycle start, single block, block delete. We have our overrides, which we have our override for our feed rate, override for our RPMs, our spindle, our override for our rapid. We also have tools available for us in the center here to set up our machine and figure out where our origin of our piece is going to be. Next, we have the stepping mode. We can select between 1/10 of a thou all the way up to 100th thou of stepping. Now that works with the step mode. I'm on the slowest mode so you can't really see it, but if I go up to 100th thou, I'm going to change it to my Z-axis. You can see every step is going to be 100 thou. And there's also continuous. Continuous, you're able to jog the machine however you would like. And that goes into setup because we got to jog our machine to set up the machine and know where our positions are. Alrighty. Next tab is file. Under file, this is where we bring in our NC codes so we can run our program. Right now I don't have any NC codes, but you can see here I have a USB connected to the device right now, and it's showing me what I'm able to choose, what I'm able to find. Maybe there's a practice. There's some practice stuff in here. Next one is settings. Settings is important to understand. This is where we can turn off our limit switches, just in case if your axis is stuck on a limit switch. So right now the X is on a limit switch because I can't move it anymore. But if I shut off the machine, turn it back on, and for some reason it doesn't want to home because it's on that limit switch, well, we have to disable that limit switch. Limit switches are disabled, and now that's going to allow us to jog off that limit switch. We can turn back on that limit switch just by clicking the check mark and then re-reference our X. So it knows the right position. That's if there's any trouble with referencing your X or Z.
And it'll give you a message saying that it's against the limit switch.
Correct.
Okay.
It'll give you a status error, and from that status error,
You can see. Okay.
Offsets. Offsets is where we can choose a tool that we're using and set up the tool so the machine knows where the tool is in correlation to the part. We also have offsets table where we define our G54 and our tool offsets. Both offsets are here, tool offsets and work offset. This is where you set your part and this is where you set your tool. Conversational is a way of programming the machine through Pilot. These are quick runs. Now we have OD turn, ID turn, profile, base, chamfer. So if you need to face something real quick to make a smooth end on it, we can go over here to face and face off our material. And we will get into this a little later. But as you said, status is going to show us all our alerts on the machine if something's not working properly. I'm going to quickly e-stop it. And you can see machine recording saved to e-stop videos. So it's just letting us know what the status of our machine is right now. I can take it out of e-stop. Reset. Reset. And I can reference X and I can reference Z again.
Just like most of our other machines, anytime you hit the reset, you're going to have to rehome it.
Yes.
It's lost it.
Yeah.
Okay.
Now, I'm going to go ahead and clean some stuff off here. There's a lot of configurations to this machine. One of them I'm going to show you is this chuck. So you can actually remove this chuck to have collets at the same size as your material. So instead of using this, you can use a collet to tighten down your material. But to do that, we have to open up this panel. Lift the panel up all the way. This is what locks it here. We can release this to unlock it. Same with this door as well. Now, the way that this is, it spins, so we need to lock it. The locking mechanism is actually here. So when we press this down, all we have to do is loosen this. The tool to loosen that is going to be in the toolbox. And all these toolboxes are shipped with the machine. A couple tools in here.
Mostly metric tools.
Yeah, it's probably like a 17mm wrench. But we can use this tool. I don't know if you guys can see that. I think this is a smaller one. There was a bigger one, I believe. Yeah, I grabbed the small one. So here's the bigger one that's going to allow us to loosen this up here. Got that in there pretty good. Should be tight because as it spins, you don't want this to ever come off. There we go. And that frees up the chuck here. You gotta wiggle it a little bit. It's on a heat-link slot. It's all greased up in there too. I'm actually we're going to keep using that today, so I'm not going to take it out all the way. Okay. But that's how you would take it out. I'm going to show you, see if I can find them. There should be collets.
So like you were pulling on it.
Yeah.
It should come off just by pulling, wiggling, but if it's not wanting to, is there any trick to...
I guess hitting this with a mallet here. But that could throw it off. You can possibly get a screwdriver in here and kind of wiggle its way out.
Kind of jiggle it back and forth.
We should probably make sure it comes out before
Well, yeah, that's, if it's supposed to come off, we want to make sure it's
Yeah.
gonna come off.
This guy slides all the way out. The way it really goes is it's threaded here.
Yep.
There's a thread back here. There's also a keyway slot that this slots into. But yeah, I'm not sure if I can actually get that or not. But I do want to explain what these collets are, though. These collets can hold certain size materials. So if you had an 1/8 of an inch or 1 inch, 1/8 inch round stock, you can actually put this in instead of your chuck and clamp down your material that way.
Yep.
So that's what these collets are. Not sure why that is so hard to remove. But with this chuck, you can really do any material, any sizes that this has to offer.
Right. That fully adjustable.
Yeah. You still want me to try to take it out, or?
I,
We'd want to make sure that it's coming out, but I mean, that could be done later.
Gotcha. I'm gonna try to
No.
find my flat.
do it in post-production.
What's that?
We'll do it in post-production.
Yeah, yeah. Yeah, we just want to make sure that it's going to be,
No, of course. The other
Correct.
machine at the other school was a lot easier than this one. Must have left my flathead in the other room, but there's a flathead here. Not much. Why is that so tight? Sweet. Maybe
Okay.
try to wipe this up a little bit. That's just lube in there. It's not scratched up or anything there at all.
the lube, is it solidifying, like getting hard? It's like it's been in there for a while?
No,
Okay.
it's not hard at all. I can wipe it. There's no rags here. Always
We
there.
just use paper towels.
Okay. Now I can show you the I wonder if this is the same size as this one. No, completely too big, so we'll have to use the adjustable
Yeah.
stock anyways. But
Okay.
this could fit a lot of the materials that you have up there. And you just put your material in, tighten it down with the
From the backside.
from the backside. And you're able to clamp down the material with these collets. No burrs or anything. That's good. So there's that keyway slot.
Yep.
That keyway slot will line up with the pin that's sticking out here. once it's tightened. Maybe I don't tighten it as tight that I did last time.
Yeah. I'm wondering if it's not kind of like our mills where you loosen it a bit and then actually give it a wrap on the top, which bumps it forward, and then you loosen it the rest of the way.
I see what you're saying, like
Yeah.
unloading a tool.
Yep.
This one is kind of like that, but I want to say it is just squeezing it in there.
Okay.
Cool. We're gonna lower this down. This is all ready to go. Take this, put this back in here. Now loading up our material. We have our quick chuck release here. We have our tool that loosens and tightens the 3 prongs on our chuck. Make sure it's open up enough to fit my stock in there. Once we have our stock in there, we can close the jaws on it. That's quickly how we would set up our material. We also have a lot of tools that we could use to cut this aluminum. Put these up right here, kind of set them on top up here as well. Now a lot of these offer quick change. So once you set the tool up in here, all you have to do is slide it on the slot and it's ready to go. Hinting the name quick change. Sweet. Now, our tool will actually sit inside the hole, the corresponding tool. So this could be for boring, outside diameter turning. The way it actually sits in here after we have our tool set in the slot or in the hole is we can put it down, make sure that these are up, and then to tighten it, what we have to do is turn this. Now I gotta tighten that nut up here. This nut's loose. That's why it's all wiggly and wobbly. And it looks like we have to tighten these Allens too because they're not squaring our piece here. So these 2 little Allen screws are for squaring our tool holders. 2 little Allens here. So I'm gonna find an Allen wrench that I can use. To square that off. Now once you square it off, you don't really have to do it again unless you're worried about tolerance. One of these has to work. We can also get a wrench to tighten this down. So the wrenches here, yeah. This is what this wrench is for. It's not what that wrench is for. Millimeters, 14 millimeters. this is all good because now you guys are really going to see deals has to be done in order to run this machine. So just tighten that top screw up there. So that whole thing just feels super loose. I'm just gonna have to tighten it down. Wow. The reason why Tormach actually has these loose is because you can actually move this about half an inch closer to the inside of the machine. Yeah.
What's the purpose that they allow for that to be moved in closer?
Inside diameter boring.
Okay, yep.
But we want to make sure all these are snug down or tightened down because we definitely don't want these moving while the machine's turning that piece super fast.
Right, won't hold the tolerance and the project won't turn out. Worst case, it comes off.
Now, I don't have one on me today, but if you had a dial indicator, if you guys know what a dial indicator
Yep.
is, you can use a dial indicator to make this true with your x-axis and z-axis. Oh, z-axis and x-axis. What that means is, while you're jogging it on the x-axis, you want to make sure this is parallel or this is parallel with that axis.
And to adjust that, where's the adjustment?
You have to loosen this, right?
Yep.
These two screws right here are your adjustment to dial indicate that
Okay.
in perfectly.
Okay.
Sweet. So with these quick change tool sets, well, we actually have all the bars for inside diameter and OD turning. You even have left hand and right hand tools. I'm basically just giving these all on box, sorry. Just want to show you guys each and every single one of these. This is a boring bar that can go inside your piece of material and hog out that material. The way I actually use this one is first I would drill a hole using my drill chuck right here. So you load up a drill in here and then you can drill out the hole of your material. With this, we'll sit here. Obviously this is going to be closer and we can go in there and clean out as much material as we need to in order to get the final inside diameter that we need. This is a nice one right here. This is a slotting tool that's used to cut off your material after you're done. So you can come up here with this as it's spinning. This will go down, 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 down to the middle, and then it will pull off. Turning, facing, perfect. That's the one. Now I'm going to show you how to actually build your quick change and put your tool in there. Sweet. We can see that we have our slots here to slide it onto our quick change system, but on the back side is where we can actually put our piece, but we have to loosen the Allen screws for that. Oh, sweet, there is an Allen set in here. It's probably all the right sizes for this machine too. It's a 3mm wrench that we're going to use to back these out. Now, the way this goes in here can be two ways. What we have this way. Now, if we put our bar in here, that looks wrong, right? Well, it could be right. It could come from underneath. Or, you can have it this way. There we go. Now it's sliding in there. Nope, that one's too. This one's not screwed enough. Now, depending on the way that our spindle is spinning, we want to make sure we set this accordingly. Or make sure we have the right, the correct left-hand tooling or right-hand tooling that we need to cut our part. What I'm going to do first, just actually spin your spindle. I want to set our RPM here, so it's to 100 for right now. Just enter invalid RPM setting, so it doesn't like 100, try 200. Yeah, that works. I'm just going to click forward. It can't start, so I got to be in the main tab. Now I'm going to click forward. Enclosure door must be closed. I just want to see which way it spins. So I'm making sure I have my part in here correctly. Oh, there we go, the main tab. There we go. It's spinning counterclockwise. And our piece of material is not straight in our chuck. So we have the wrong tool in here. We need the tool that's going to go make sure it cuts. So you see which way it was spinning counterclockwise, right? If it's spinning counterclockwise in this tool, and this tool comes over here, right, and tries to cut it, it's not going to cut anything. It's just going to hit the back of our tool and possibly just break it. So we have our right-hand cutting tool or left-hand cutting tool. I can't tell the difference. That's why I'm referring to them as both. That's why I checked my spindle, make sure it's spinning the correct way I need it to. So now when it spins, it's going to go into the insert and be cut. And that's what we want. You can have this sticking out as far as you want. This is because we can set our tool length offset however we want to. Now, this piece right here, it actually sets up our height of our tool. So when we start using that tool, you can see it stopped because this is setting up our height. Okay. Now, we want that height to be about the middle of our material. I'm actually going to jog it closer. So if this machine tried to face off this part right now, it's actually not going to face it all the way. That's because our tool is not centered at all. So we got to make sure we set this correctly in order for it to reach that center. And once it's there, this is where you lock your nut so you save that position for this tool. I'm just going to quickly eyeball this since I don't have any dial indicators or anything. But as long as you guys got the concept, you can use your measurement tools to get this super perfect.
Now with the material not necessarily being completely centered in it,
Correct.
is that gonna?
Oh yeah, that will definitely affect it.
So gotta correct that first.
On this side. Now, assuming that saw it straight, we should be super close. No, no, we're close.
How much is going into the jaws of the chuck of the material?
All the way until it hits the back.
Okay.
That's why that could not cut straight for like, no, you know
Right.
what I mean?
No. I just didn't know if you had it going back far enough, if that would make a difference, but if you're going all the way through, it should be there.
That time I just took it off the back a little bit. Yeah, 100% better. What do you think about that?
Yeah, it's not perfect,
It's
but,
not perfect, but
you
it's
know,
close.
my experience is most of the time when you're first starting out, it's never 100%, but you're looking for it to be close.
Sweet. That looks a lot better. This now. Yeah. Work. Go down one.
So you basically just jogging it in towards the center.
Yeah, just
and
kind
then
of
eyeballing it as best you can.
Visual, yeah.
Yeah.
Just eyeballing it right now. I don't have all my great tools. I would use a dial indicator to actually get that perfect. I want a quick wrench to tighten down that top nut. Sweet. Nope. $12mm. Nope. Probably not definitely works. Or 10. Yeah. So now that saves the position of our
Yep.
piece. Get that out of there. Put it back in. Should go down in the same spot. And that's money. Perfect. And we got this pretty good. Now it's really just setting up our machine. We don't have a program to run right now, but I want to show you guys how to do the conversational programming. I want to base this off.
Okay.
I want to make this a nice, clean base for us. What I'm going to do first is actually set up the machine. And the way I'm going to set up the machine, if there's any paper, I'll take a piece off of this. But basically just step it in there until we have no clearance. So I'm going to claim that this is my Z0 all the way at the end of my part. Set on my Z, just step it. Now the difference on this, the stepping is the inside wheel, and the jogging is the outside wheel. Jogging is the outside wheel, stepping is that inside wheel, remember that. Another trick you can do, other than this way, if you're worried about students setting this up and crashing it, you can actually use a marker and paint the front of this. You can spin the chuck, and you can also see when it actually touches. That's usually my way of setting that up sometimes. But like I said, we want that to be our Z0, and to actually make that our Z0 in our G54. All we have to do is click on the Z0 button here. You can see our Z is zeroed at that position for our tool. So now our tool knows that is Z0. But if we look here, our X is at the wrong diameter. We got to set up X and make sure it is the right diameter. Because the center, right, should be 0. The center axis, or the middle, very middle of this cylindrical stock, should be 0. Does that make sense? Do you happen to have an Expo or dry erase marker?
I have marking die.
Yeah, I guess that'll work. This is the trick I'm going to use right here.
Permanent marker, dry erase,
Okay.
permanent marking die.
Sweet. Offsets here. Paint around here. And I'm going to step in the X. X at look now. See if I can do this in front of the camera. Do you also happen to have calipers by chance?
Yeah.
I do need to measure the exact size of the stock, and then from here, it's going to tell where the exits go.
This one zeroed or?
Now we're going to grab the measurement of our round stock. Which is dead on at 1.5 inches. Just wanted to make sure. I'm going to enter that 1.5 inches here. I entered that 1.5 inches here. Now, if I go ahead and jog this over to the center, that should read 0. I don't know where the center is, but I got as close as I can. You can see our value is super close to 0. Now, if I go to 0, then most likely I'm going to be perfectly at 0 on the center. So now the machine knows how big our actual part is. We're ready to make a conversational program. Ready to make some chips?
Sure.
Alrighty. Under conversational, I was talking about we have OD term, ID term, profile, face. I want to go ahead and face. Now, it's going to ask us what type of material this is. It is aluminum. It's 6061 aluminum. The work offset that we're going to be using is the one that we've been setting up down here. And that position is in G54. If I go to my offsets page, we can see our G54 is set at -3, whatever values it gave it while I was setting it up. Now we got to tell that to the conversational parameters here, G54. And now we have roughing SFM, finishing SFM, which means speed, surfacing feet per minute. So that surfacing feet per minute, I'm going to go around for the facing. I'm probably not going to take off a lot unless I want to clean off this chamfer. If that's so, then my roughing SSM, I'm going to have it at around 500. Finish SFM, yeah, 600 instead. Finish SFM, I'm going to do slower, 400. Max spindle RPM, let's go 1500. Inches per revolution, roughing inches per revolution. Inches per revolution. I'm not thinking in lathe right now, I'm thinking in inches per minute, feed rate.
Mm-hmm.
This is inches per revolution, so it's a little bit different. I'm gonna go 20, aluminum. Let's go 10. 10 and 12. Something nice, easy, and slow. The tool that we're going to use is the tool that we set up. I don't think we have to. It's not giving us an option to change tool. Okay, right here. This is where we change it. So we do have to go to offsets, go to tool touch, I guess, and then we have to change our tool in here. So now tool 1 is set, or tool 1 is defined as being active right now. If I go to my offsets table, it has whatever value that it gave it. But we don't have to actually change anything or touch the Z or touch off X. But you would do it the same way I just did. How I marked it here, marked it around. As I turned it, you know, it scraped it a little bit, but it's still scraping the paint off. And that's how. This is how you would actually touch off your tool. You can see your center point for your tools at 2. That's how it looks right now. Now, when it's at that area and you click Touch Z, it's going to set the offset for the tool, but we don't need an offset for the tool since we did our offset for our work offset with our tool, believe it or not. It's a little confusing of what I just said, but if you're thinking about it as the mill, you can set all your tools to the same Z value and not ever have to touch the electronic tool setter on the for all those tools. That's exactly what we're doing here. All right, just wanted to make sure that we are using 1, and we have it here changed to tool 1. So now I can say, hey, our tool 1 is ready to go. Now, the initial X, use negative X values to have the tool work the negative X side of the workpiece. Well, we don't want to work the negative X side of the workpiece because we're on the positive side. So, that's only when you want the tool to work the negative X side of the workpiece. So we're going to keep all our values positive. Our initial X, it looks like it's 1.5. That's our start, our initial area that we need to machine off. Our final, well, we can go down to 0 because this is spacing. We want to go all the way. Now with the Z start, well, we set our Z at 0. We know that. We tested that. So that's where our start's going to be. And our end is going to be in a negative. I'm only going to give it probably a 10 thou. Just quick surface, make it nice and smooth. And we can do more if we want to, but I'm going to have you guys do that.
I'm good.
Sure.
Yeah. I'm fine. I'm good.
Tool clearance gives us clearance for our tool. I'm going to give that at a 1/4 inch of clearance. Roughing DOC. I'm going to do that at 0.01. We don't, I guess we don't really need to really set these because we're only doing 1 depth. DOC means depth of cut. So this is the roughing depth of cut, finish depth of cut. I'm going to set this to 0.01 as well. And we can click post to post this, and now we can run it.
Yep. So if you set a roughing depth of cut and then a finish depth of cut, if you wanted to do just a rough and not a finish, could you just have the finish depth of cut just 0?
Correct. Yeah, you can have this at 0, and it's not going to affect anything.
Okay.
Now, this finish depth of cut will still probably need to be set to know that we need to go.
You need to go, yeah. So, right.
Just
But if you just did a rough cut and you weren't going to worry about a finish cut,
correct.
You would leave it the same. So 0.01, 0.01, or if you didn't want it to do a finish cut, could you have the finish cut at 0?
I guess for roughing depth of cut, it's depending on how much this tool can actually handle. I'd probably only cut off 50 thou at a time with aluminum to just get where I need to be. So if I actually told it, I want my Z end to be, I want to clean this all the way to the end of that chamfer, right? Well, whatever that chamfer is, let's see. We say 1/4 inch minus 0.25. Well, it's going to do a lot of these roughing depth of cuts before it actually does its finishing cut.
Right.
And we can do that. I'm actually going to do this a lot less.
Is there standards on what you should do, or is each time different?
So the speeds and everything that I'm saying here, I really just, it's personal experience that I've been through, and
But like the clearance and the roughing and all that, is that a benchmark that we can use for our students?
Yes, that is a benchmark. So if you look, the clearance is how much clearance do we want to give our tool before it actually engages into our part. So that clearance can be set to anything. I can give it a 1/2 inch clearance, and what that's going to do and look like before we even run it, I'm going to show you. our tool is going to stick out half an inch before it even gets to our first area where it needs to cut. That's our clearance.
Right. And
Now,
typically your max depth for most cutters is 50 thousandths.
correct, yeah.
Yeah.
Since this is aluminum and we don't have coolant, unfortunately, yet, I do want you guys to get coolant. That's a must need on this machine for sure. That's why I'm hesitant on running that roughing at that high. I'm going to go down to 25 thou and we should be good. Perfect. Let's go ahead and shut this. We are going to click post. When we click post, it's going to give us a facing NC file that will save onto the computer's memory.
Yep.
We can see it created our program, and we don't have a lot of G code because it's just facing. Facing takes, it's pretty quick, but it looks like we still have about 10 passes before we can even, or before it's even finished. And that's because we're cutting at 25 thou. Now, since this is the first time running the machine, I am going to personally single block it. Single block allows us to step line by line so we can verify our first operation. If everything looks good here, then we can always just turn single block off and click cycle start. Since this is the first time, I'm not too sure, not too positive, but we can click cycle start and start stepping line by line. What's nice is it tells you what G code this is explaining what G code is given to us. G7 being our diameter mode, G18 our XC plane, G90 absolute distance mode. Now, do you know which plane that Tormach 1100 uses?
I don't remember. I'd have to look at it.
It uses a G17 plane, an X and Y plane, because it's moving on the X and Y.
Yep.
G90 absolute distance mode, G40 turn center compensation. I'm just going to keep clicking cycle start. It's going to go through our work offset. G30 is going to park the tool, which it's G30 is its home, basically. It's going to call it tool 1. And the tool code is different than what the mill would show. So this is T0101. That's tool 1. We click cycle start. And now it's going to give us our, it's going to start turning on our spindle here. It's a nice speed. Start. Now, G0 X2.5. That's going to move our X to, well, 2.5. Right now, our X is at 1.8481. We're expecting this tool right now to move this way to get to that 2.5 area of clearance. Perfect. Did you see it? I don't know if you saw it move, but it just moved. The G0Z 0.5 is going to move half an inch. That's a half an inch of clearance that I gave you. G0, since it's a G0 movement, that's controlled with a rapid. So this override that I'm moving around right here controls that G0 line. If I click cycle start, nothing's going to happen. That's because I have 0% of my rapid turned on right now. So if I slowly turn it on, you see the machine keeps going until it gets to its destination. Now the reason why I'm controlling my feed rate, or the rapid feed rate, is because I want to make sure it's getting to that 0.5 and not crashing into our part. You see we have about an inch to go. We do have an inch of clearance, so we know it's not going to crash. It's going to the right spot. I'm going to let it run all the way. Perfect. Sweet. And just keep going. I'm confused now. Why does it say 2.5 and the tool looks like it's right? I may not have set up the X incorrectly. I'm going to feed hold stops the machine, and then reset to reset it. That doesn't look right. If I go jogging on the X, go to 0. Yeah, it doesn't know where 0 is at anymore, so I gotta reset it. Maybe. Okay, so that's probably what happened. These numbers are affecting it since I set up a tool 0. Tool 0 had 0 definition, and since I told it to use tool 1, well, that tool 1 had definition in it, and that's what's affecting it to go to the wrong position. So that's all my fault right there. I'm gonna go ahead and go back to the conversational and recheck everything. Make sure that X is going to 0 now. Perfect. Right there. Initial 1.5, final 0, post. Save. Overwrite it.
Yep.
Single block it again. We're still using tool 1, but we're at the right position this time. And now I'm going to keep going again. And that's why we verify our deal, so we're not going to crash anything. I totally messed up there, and I caught myself. Sweet. So it's going to turn back on the spindle, and we're going to get going. That looks a lot better. Now that tool is far away from that area. It's going to go to its first area to cut. And now it's going to run to 0, G1, X0. We're going to go ahead and click cycle start, and now we should see some chips. Or we can see the tool blow up. Anything can happen at this point. Yeah, I'm going to keep it on a single block. Here we go. Went too fast. So back to 0, C0, just back that way, back to there.
I'm gonna guess in the program.
I'm gonna control the feed rate now. I should have controlled it last time. G1 is controlled by the speed rate override, so when I click cycle start, nothing happens. I can go as fast as I want, and I'm gonna look at my feed rate to see what's a good feed rate to use to not blow out this insert on the first try. But we will be good. Whoa. It's moving. That's at 1%. So that feed is just way too fast. I'm going to just feed hold, reset, and go back to my conversational tab to fix that.
Yep.
And that could be from our SFM.
Or the roughing inch per revolution. I'm guessing that should be like a decimal number.
I'm thinking that too. I'm probably still thinking inches per minute, which is way different than inches per revolution.
Right.
Let's do 0.25. 0.25. We'll just do both the same and see what they look like.
I'm actually wondering if try 0.01.
0.01? Okay.
Yep.
And we'll post it. Save. Well, since it's already cut, we know it's not going to cut on the first time, so we can see how fast it can go. There we go. Yeah. Inches per revolution, perfect. Nice and controlled. Believe it or not, our insert's good. Beautiful, and look at that. Making chips. We want to see chip evacuation because that tells us that our insert is cutting and not burning or melting. Second start. I'm going to turn off single block now that everything really just looks good. Sweet. It's moving inside the truck a little bit. I can see it wobbling. And obviously I wasn't perfect on my setup,
So it's leaving a little nub.
it's leaving a little nub. Oh, my tool completely came out too on one of those heavier runs. If you see, our tool is
Oh, in the office. Yep.
I might have been thinking too fast. I don't know if I actually tightened it or not, to be honest. I guess now, we have a little nub there that we can kind of use as our center point. But that's kind of the idea of this machine. But
Yep.
thank you for that inches per revolution. In my mind, I can't think of inches per revolution really.
Yeah.
It's inches per minute. I'm a 5-axis programmer.
Yeah, I was thinking of what I've used in that situation on the mill, and I want to say it's around that 0.01, 0.005.
100%, yeah.
Yep.
Alright, I'm going to set this tool up real quick and see if we can get this spacing all the way done now.
So now you got a better eyeball point to hit.
Yeah, that's what I'm hitting right now.
Yep. Yeah, on the manual lathes, I normally have the kids eyeball it, make a first cut, readjust it to finish it off if they didn't get it perfect.
Yeah. This is great. This is great right here. So I can actually loosen this up. Those chips look good though.
What's that?
Good.
Yeah, you put dollars.
Okay, whatever.
We had a call guy
Okay.
do this again. Since right about there, I'm going to try to zero it from that point. Zero, zero, zero. So I'm just telling the machine, hey, that's my Z0 for my X and Z, and if you look at my tool, it's, well, right there. It should be at Z00. Jog it off there now. Go back to conversational, and we're going to rerun this spacing program, and everything should be dialed in. 25 thou, end is at 1/4 inch. Points can now go. Well, it didn't even do a 1/4 inch, so I'm going to keep it at 1/4 inch. Yeah, everything looks good. I'm going to post it, save. Override, go in here, single block, turn it off for a sec, single block on, that's better, got that nub already, second start.
So because you got it on single block, it's slowing down between each block, kind of bringing it.
Well, the reason why it slows down and then starts speeding up is actually because that's our surface speed per minute.
Yep. Cause the whole thing, the whole piece to jump.
I saw that. That was only a 1/4 inch part insert. Looks good. That's the other thing with this machine is you can lift it, it's going to stop. You're safe to go in here, do whatever you need. So this is coloring and it jump. We need more. Need more or less? What does that mean? It's cutting.
I would say the feed rate is too fast.
Still too fast. Yeah. I would say the same thing. Let's slow that down. Looks like we're going to turn on the RPM. Reset. Is that still pretty good? Yeah. So yeah, we'll slow down that roughing feed rate. 0.0. Let's try half of that. You agree with me?
Yeah.
Sweet. Now let's go ahead and post this again. jumped it again, huh?
Mm-hmm.
On my feed rate at 60%, probably go to 50%. So inches per revolution, 0.002.
Okay. So how would that correlate if you have the feed rate like 400 or 600 inches per minute on it? If you slowed that number down.
Are you talking about the SFM?
Yeah, surface feed.
So the surface feed per minute, what that's doing
is your rotational.
It's your rotational. It's keeping it constant all the way through. The inches per revolution is what I just needed to dial in. I didn't really have that dialed in, but now I feel confident that this is good. And it can also be as the stock sticking out super far and it's super heavy as well.
Right.
That there's a lot of factors at play here.
If you're running a different type of material, would all your settings be different then?
Correct. Yeah. If it was steel, I'm probably doing everything 5 times as slow. Take off some more. Just let it run. And that's why the SFM is controlled also by your maximum feed rate. My maximum feed rate, right? So when it gets to the middle, my maximum feed rate should be around 1500. On the outside, it slows it down because on the outside, the tool has to travel longer versus.
So at what point are you done with that? Do you keep going, or do you have to?
Oh, so my
or do you have to stop it?
No,
we're full control of what we're telling it to do right now. I told it to cut a quarter of an inch, so it's still finishing that quarter of an inch facing that I told
it's just doing it in increments.
Yeah, I realize that. I didn't know that he told it to do a quarter of an inch.
Oh, good. Yeah, oh, good. And this is now that 10th thou pass. Done.
Or is this the finished pass?
This is that finished pass.
Yeah.
That was the best sound the machine made all day.
Yeah, and I was just kind of looking at where the surface feet per minute was at. It was like 60.
I'd say between 400 and 500 for sure.
Okay.
But look at this. Take a look at that, how smooth and nice that finish was at the end there.
Yeah. Pretty darn close.
So that's basically just the ways how to use the conversational. I think you have V-carb, you said. Let's go. I want to go see what your V-carb has to offer. As everything here for setup, I've showed it all really.
Okay.
That's everything with the machine. You guys have any questions right now for me?
So like doing a profile.
Profile, yeah.
Yep. So you got to know from here because you need to end before the going in.
Correct.
Right. Is there a safety feature in the machine that prevents you from doing that?
Are you talking about safety?
Running the tool into the chuck.
No. So you can do that. So you have to be aware of that. That's why I personally set my C0 at the end of my stock here.
Yep.
The only reason why I do that is because I know anything negative, I'm going to cut. But if I cut too far in the negative, then it's going to hit my vise. Or
Right.
you can do the opposite. You can have your negative or Z0 here. So you know anything past that Z0 point, it's going to hurt your chuck.
Right, so you want to, once you set it up, make sure that your program has a little extra material sticking out.
Yes.
Okay.
I would always give yourself half an inch to an inch of extra material, even extra material because you have the clamp in, right? But always give yourself that extra material so you're not hitting that vise. And that's why I told us, let's do a 5-inch one because we have a lot of possibilities here just using that much material.
Right. Okay. Is on the profile setup,
Yes.
is there any specifics that are different from the face that, as far as dimensions that we need to
So
understand?
you have to keep in consider your tool. Your tool, this one in particular, can only, I guess can only, I need like a pencil or paper to really write it down, if that's all right. So if our material is in here, our tool is coming in to cut it. Our tool is shaped this way.
Yep.
That allows us to only do cuts like kind of like this, right?
Right.
If we try to do it backwards cut, well, that tool is going to fail. That's because this geometry can't actually get into
in there.
We have to make sure we're using the right tooling so something like this can get well in there. Does that make sense? That's something
Yep.
you just got to keep in consideration. As far as the setup goes, show the camera real quick. As far as the setup goes, it's planning out your that's profile points. The profile points will be the points where your tool needs to go, or where your tool needs to go. Those profile points, you're setting them on the X and Z where you want telling this tool to go from point to point.
Right.
That's how you can do it here. Roughing / finishing, you have your roughing depth of cut as well as your finishing depth of cut. So I have the finishing depth of cut there, yeah. Roughing depth of cut 20 that, perfect.
Yep. So the profile points would be kind of along the profile, how far down, where
Yes.
you would make a change in your profile.
Yeah. Now, for example, right? If I want to go and just clean up an inch of this, well, we got to give it our X value. Our X value that we want to go to is something under 1.5. So 1.45, we're just cleaning up 50 thou, or basically 20 thou material, 25 thou of material on each side. On the Z, we're telling it points to point really. So Z, if we start at 0, we can start at 0. 1.45 to Z, just go -1 inch back. Does that make sense?
Yep.
So now I'm just telling it to, well, I made a line from here to here.
Yep.
And it's just going to clean that
Right.
25 thou.
Right. And so your Z, everything needs to be negative as you're heading this way.
Yeah, as you're cutting that way. And that's depending on how you have your Z0 set up. I can have my Z0 set up here. Now all my values are going to be positive. I just got to know the distance from here, my Z0, to the end of stock. Whatever the end of
Yep.
stock value is, that would be your starting point. It would be a positive number. And that's just all depending on how you set up that Z.
Okay. Now, if you set up the Z closer to the chuck, is it going to feed going the other direction, or is the feed still going to be going towards the chuck?
You're still going to be going towards the chuck.
Okay.
Yep. Unless you told it otherwise, but usually it's always from point A to point B over here to the chuck.
Okay.
Sweet. Any other questions?
Not that I can think of right now. Got any?
Let's go take a look at V-carb and see if there is a lathe application on V-carb.
Okay. Yeah. We can fire it up.
Sweet.